Hi everyone. In the given problem statement, we have to find square root of x. So we have to be given a non-negative integer x and we have to find the square root of x rounded to its nearest integer. So one way of solving it, right, let's say in Python, right, I can have x and x multiplied to the power of 0.5, right? It's the square root and I can convert it to integer and it is going to give me the result. But right here it's been categorically written we cannot use power function. So other way of solving it, right, we can use a binary search. So let us take this example. I can have L and R, which is going to be 0 and 8. So I know while L is less than equal to R, so I can find the mid value. So mid would be 4 in this case. Now I can say, let's say, target would be mid multiplied by mid. So if my current target is less than the x, the value that we got, right? So here in this case, right, the target would be 16. So it's not. So I can say elif target is greater than x. In this case, right, 16 is greater than our 8. So I can say r equal to mid minus 1, and in this case it would be l equal to mid plus 1, and else, right, I can just return mid. So in this case, right, how it's going to work, I have done r equal to mid minus 1, so it is going to make, right, my r value to be 3. Then I'm going to again calculate, right? So 0 plus 3 is divided by 2 is going to be 1. So mid is 1 currently. So 1 into 1 is 1. So in this case, right, if target is less than equal to x, right? So in this case, it's true. So my current L would become 2 out here. So I'm going to get the value. So now again it would be 2 plus 3, which is going to be 5. Double divide by 2, it's going to be 2. Mid is 2. So the value of target is 4. So here, right, 4 is less than 8. We get the value, right? So I can make again L equal to mid plus 1. So my current mid was 2, right? So if I increase it, it becomes 3. So it will become 3. So if I got 3, right, now if I calculate again, the mid is going to be 3, target is going to be 9. 9 is greater than 8, right? It's going to come in this part. So R is going to be minus 1. So R is becoming 2. So R become 2, right? And our current uh, L, right? Our current L value, right, was 2. So in that case, right, this loop is no longer proper, and I can return the L value. So that is the basic general idea how this is going to work. So if I write the Python code, I think many of these things, right, is going to get clearer. So let me jump to the Python solution. So here, right, I can create my left and right pointer, which is going to be 0 and x. So while L is less than equal to R, I'm going to find the mid, which is going to be L plus R double divided by 2 to get the integer value. And I can say target equal to mid multiplied by mid. So if target is smaller than X, then I can say L equal to mid plus 1. L if target is greater than X, so R value I'm going to decrease by mid minus 1. And if its value is equal to X, right, I can return the mid. Now there could be a situation, right, where the value that we're going to get, right, it could be an integer, like it could be a floating point value. For example, the square root of 8, right, is 2 to the power 8 to something, right? So I can say, right, I can return, I already explained you the logic. So there I made one mistake, which was that I was returning L. Instead of returning L, right, I'm going to return the R. So I have to return R. So let me run the code. I think it should work fine. As you could see, the public test case is passed. Let me submit the code. And code submission is successful. It is beating 41.72 of the submission. I'm pretty sure somebody might have solved it in just linear time. Let me check if I solve it in linear time, how it's the efficiency coming. But although, right, we cannot do it because it's been categorically written, right, we can't do that. So it would be like int of x to the power 0.5, means it would be big of 1 time complexity. Let me run it, although I would not advise you to do that. As you could see, it's beating 100% of the submission. But for your sake, right, of understanding the problem, go with the binary search. That's all for this video. See you in the next one.